Electric field intensity or electric field strength. What is electric field and what is field force? What is field force? I'm trying with a simple experiment that what is field force. What is field force? Now, the force acts at some distance. I'm repeating this experiment. These two are magnets. Now, I'm not touching the magnets with each other, but the force also acts. Similarly, now by using another experiment, now there is no force between duster and the marker at some distance. Now, without physical contact, there is no force. And in magnets, at some distance, there is a force. It means the force between duster and the marker is not a field force, but the force between these two magnets is a field force. Field force is a force that acts on another object at some distance without any physical contact. So the magnetic force is a field force, the gravitational force is a field force. For example, now at this duster, the gravitational force acts in downward direction, but there is no physical contact. And also electric force. The force, for example, the force between this positive charge and this positive charge is a field force because there is no physical contact, but still the force of one charge on the other is acting. So the field force is a force that acts on another object without any physical contact. Electric force, magnetic force, gravitational force are the common examples of field force. So it's a field force. What is electric field? The region or space. It's a positive charge, and these are the field lines. What is field? The space or region around a charge in which another charge experiences a force, feels a force. This is the electric field of this charge. What is electric field? An electric field is a type of field force similar to magnetic field, gravitational field. The space around a charged object, this space around this charged object where another charge feels a force known as field of that charge. Now what is electric field strength or electric field intensity? They both are same. Now electric field strength. Force of this charge on this unit charge. This is a source charge, this is a unit charge. Is known as electric field strength. The force is stronger near the charges and weaker as we move far away from the source charge. Means here the force is weaker, here the force is stronger. So force on a unit charge is called electric field strength. Force per unit charge is known as electric field strength or electric field intensity. Electric field intensity means here two lines are touching the charge, here a single line. Means intensity is increased, strength is also increased. Here strength decreases, strength also decreases. Now we know that according to Coulomb's law, F is equal to K Q1 Q2 divided by R square. Now it's a source charge capital Q, a unit charge small q, yeah, q naught. The force of this charge on this unit charge, q1 q2 divided by r square means q naught divided by r square. K is equal to, by putting the value of this force, F is equal to k q1 q2 means q naught divided by r square, and this q naught is as it is, they will cancel out. The electric field strength is equal to kq over r square. Now the vector form, in vector form, here we discussing only magnitude. In vector form, put the arrow on the electric field, then unit vector also. It's a unit vector having magnitude 1. And the direction of unit vector is same. Direction of electric field is from positive to negative or away from positive, and the direction of unit vector is also same. They both are parallel. Now Q is the source charge, R is the distance. This Q is the source charge, R is the distance between the source charge and the test charge. R is the distance from the center of this charge to the center of source charge. Q naught is the unit positive test charge. Unit positive test charge. Unit positive test charge. It's Q naught. Unit positive test charge is Q naught. So what is electric field strength? Force per unit charge in an electric field. Electric field strength is the electric force per unit charge. It's a unit charge, a unit positive test charge. You can consider unit positive charge as a single word. At any distance, at any point in an electric field is called electric field strength at that point. Now mathematically, consider a unit positive charge Q naught experiences a force F in an electric field of field strength A. Force per unit charge, electric field strength. Now we already did here, up to here. Now it's SI units. Its SI unit is Newton per Coulomb. Force is measured in Newton, charge is measured in Coulomb. So electric field strength is Newton per Coulomb. Its SI unit is Newton per Coulomb. It also equal to volt per meter. Here's a proof. Volt per meter is equal to Newton per Coulomb. It is a vector quantity. Its dimensions are mLt power minus c power minus 1. Now, a conceptual question, a short question. Prove that volt per meter is equal to Newton per Coulomb. I'm taking left hand side. Volt per meter? No. What's the value of volt? Volt is equal to joule per coulomb. How? I'm explaining. It's a positive charge plate, it's a negative charge plate, and here we have a unit positive charge. Test charge means we have a positive charge simply. To move this positive charge against the field, because the negative charges are attracting, the positive was repelling. So to move from point A to point B, we need a force, an external force, or we are providing to the external force to the charge. Then what is work done? Work done is the force and displacement. The product of force and displacement is work done. Now we are applying a force to move charge from point A to point B, and it covers a distance. We are applying force and it covers a distance. Force and distance means a work is done. A work is done on the unit charge. Work is done on a unit charge. Gives the potential difference between A and B. Now, if we are releasing the charge, it will move. It has electric potential energy at point B because it's a positive charge. This positive is repelling and negative is attracting. It has electric potential energy at point A. Now, work done per unit charge gives the potential electric potential energy between A and B. Del V is the electric potential energy work done per unit charge. Or electric potential energy या potential difference is equal to voltage. Potential difference or voltage both are same. So the potential difference is measured in volt and volt is equal to joule per coulomb. Work is measured in joule, charge is measured in coulomb. So the volt is equal to joule per coulomb. Put the value of volt. Volt is equal to joule per coulomb because three dots mean because. Now by putting the value of joule, work is measured in joule and joule is equal to force is measured in Newton, distance is measured in meter. So the joule is equal to Newton meter. So put here joule is equal to Newton meter. The meter and meter will be cancelled out. Newton per coulomb is left. Hence proved is equal to right hand side. It's a simple proof that. So it means units of is Newton per coulomb or volt per meter. It's not a part of this topic. It's another conceptual questions. Now, how we can find the dimensions of electric field strength? Electric field strength is force per unit charge. Means we have to find the dimensions of Newton and Coulomb. So what's the dimension of force? Force is equal to Ma. F is equal to Ma, Newton's second law of motion. A is equal to rate of change of velocity. Acceleration is equal to rate of change of velocity. Put the value of A. Now put the value of V. V is rate of change of displacement. Velocity is the rate of change of displacement. Put the value of V. D over T. This T is at is it? Now here will be a T square. Force is measured in Newton. Then mass, the unit of mass is kg. Distance meter and time second. So the dimensions of Newton is the dimensions of kg mass capital M, meter length capital L, second time capital T. So dimensions of Newton is mLt power minus 2. Now we have to find the dimensions of Coulomb. We find the dimension of Newton, now we find the dimension of Coulomb. Coulomb, what is the current, the rate of flow of charge per unit time. T will be multiplied with the current. Charge is measured in coulomb, current is ampere, time is second capital T. So dimensions of Coulomb is A/T. Newton per Coulomb. Newton per Coulomb is the dimensions of electric field strength. So the dimensions of Newton and the dimensions of Coulomb, T will be inversed, A will be inversed, T will also, and the minus 1, minus 2, minus 3. So dimensions of electric field strength is mLt power minus 3 power minus 1. That's all about electric field strength or electric field intensity.